Welcome back to another episode where we continue to learn about the Moog Model 15 iPad app. This time let's explore the voltage-controlled oscillator. So this time we have the rectangular wave hooked up to a voltage-controlled amplifier, which is modulated by our envelope generator and hooked up to the trunk. So the voltage-controlled oscillator is kind of similar to what we've seen before in the oscillator look, where we looked at these modules, but it has some extra knobs that we'll take a look at. So it has, down here we have sine, triangle, and sawtooth, and rectangular like we've seen before. So let's take a listen to those. So just like we heard before with the other rectangular wave, it makes a rectangular wave. Let's play around with the inputs and see how we can make this thing change up. Turn the volume down a bit. Oops. So this thing does a pretty high frequency, pretty low frequency, but this is only on semitone scale. Let's switch it over to the 6-octave scale. So now it's really low frequency. Very high frequency. That's pretty low frequency right there. Try sawtooth. It also has an audio and sub-audio switch to let you go between basically an audible mode and a sub-audio mode. Sub-audio is basically for LFOs and things you can't hear. So we'll explore that later. Got our sine wave. This thing has quite a range compared to the other oscillators. All right, let's play around with the. So this section right here is well, let's just play around with this first. So rectangular width, we can switch over to a rectangular wave. Play around the width. Just like we saw before. So one thing to note is this oscillator driver doesn't seem to control this guy. So if we adjust this frequency, it doesn't have any effect. So this rectangular driver only controls these two oscillators, not this one. So the clamping point tells it when to re-trigger, or this is when to re-trigger the wave. I'm not exactly sure what the clamping point is. We'll have to look that up in the manual. So we'll play around with that later. Let's see. Let's also listen to this auxiliary out waveforms. So here we have another selector for different waveform types, or sine wave, or triangle wave, and so on. Then we have a level, basically a volume knob that we can control this thing with. And this thing is affected by the frequency right here. So for sawtooth, inverse sawtooth, square wave, which is also modified by this guy. And then kind of a smaller square wave right there. Okay. One of the things we can do is hook this auxiliary waveform out to these frequency control inputs to make it kind of self-drive itself. Let's see if we can get some interesting effects there. Let's try hooking it up to the clamping trig. Let's try hooking this up to another oscillator so we can control the clamping trig independently. Kind of interesting pattern. I think that was a good look at frequency input and the clamp trigger and the width control. There's also a sub-audio knob that we should explore. Let's look at the manual first to see if we missed anything. So if we go in here in manuals, this is the 921 in the oscillator section. So we saw that scale switch. That switches between 6 octaves and 12, plus or minus 6 octaves and plus or minus 12 semitones. The coarse grain switch switches between an oscillator, an audio oscillator, a VCO, and a low frequency oscillator, an LFO. So we'll take a look at the LFO in a little bit. Let's see, frequency control knobs, width control knobs, clamp trigger input. Use to determine when to re-trigger the wave cycle in the presence, which can provide many interesting and exotic effects. Auxiliary out section provides 6 different waveforms, and the 2 audio outputs are not identical. The plus jack is normal and the minus jack is outputted by 180 degrees. This Moog Model 15 loves to do this inverted signals with minus 180 degrees. I'm too much of a noob to understand exactly where that's used, but I'm sure more advanced synth designers can use that to great effect. Let's see. And then we have the standard 4 audio jacks, audio output jacks. Let's take a look at the LFO mode. And so we need to rewire it. So we're listening to this guy over here. Let's get rid of all these cables. And then this guy, this guy controls, let's say, a frequency of the oscillator over there. And let's put it into sub-audio mode and take a listen. Getting slower and slower. And notice we're in 12 semitone mode right here. Flip over to 6 octaves, 6 plus or minus 6 octaves. Then the LFO gets really long and crazy slow. So you can still hear the LFO going on right there. But it's really slow. If I bring it down more, you can still hear it going up, but it's pretty slow. Let's see more. It's real slow. Takes a while. And then if you bring it all the way to the bottom, I can't even hear the sound difference. Sounds like an LFO that would take about a minute to cycle or something crazy. So pretty impressively low frequency. Anyway, I think that's a pretty good look at the Moog 921 voltage-controlled oscillator. All right, so not too many modules left. We have the recorder module and a couple bridges to look at. And I think we've looked at the entire device, which is pretty cool. All right, see you next time.